So you're aiming for a grade A or a star at GCSE, or if this is the new GCSE that you're doing, then you're probably aiming for a grade 8 or a grade 9. All right, so here we go, algebraic proof. As we can see there, what you need to do is prove that what is on the left hand side could be basically whittled down to what is on the right hand side. Let's try a little trick first. I have this motto of not being too hasty to expand brackets. Look for opportunities that you can exploit. So for example, I wouldn't expand these two brackets here just yet. All I can see is a squared bracket take away another squared bracket, and immediately I start thinking of difference of two squares, as in if I've got a square if I've got a square, subtract b square, we all know that that is a plus b and a minus b. So it's the same sort of situation I'm looking at just there. So I'm going to tell my examiner that I'm going to consider my left hand side, where I'm going to manipulate the left hand side and show that I can get the right hand side. Now, like I said, difference of two squares I can see there. So let's try that out and see what happens. So that gives me a square plus, and then what I'll do is I'm going to say that this is a plus 1 plus a plus 2, and I'll put those in big brackets like that, and then a plus 1 minus a plus 2. I'll put those in little brackets and then the big brackets after. And in case I've lost you there just now, you should just focus on what I'm doing. This a square is here, and that plus is that plus there. And these are my two squares that I have differences of. So this plus that, and then this minus that in the next bracket over there, which is the same thing that we're accustomed doing as per normal. Well, let's start simplifying and see what happens. Maybe we might get lucky. So a square plus, now these brackets are not really necessary in here, but I've put them in here for a reason, because I wanted to prove a point over here. But let's see what happens. A plus a can add, because the brackets, don't really need to be there. And so in that big bracket, I'm going to have 2a. And then 1 plus 2 can add to give me 3. So that's what's in that big bracket. In this other big bracket on this side over here, a take away a cancels out, so that is now gone, no longer useful to me. And now 1 take away 2, well, that's just going to give me minus 1. So minus 1 in there. And as you can see, the minus 1 will multiply by these here, thereby giving me a final answer of a square minus 2a minus 3. Well, what do you know? I have a little quadratic here. Now, you use whatever method you want to use. I'm not going to work it out here, because if you're aiming for an A or an A star, or, or grade 8 or grade 9, then you should be able to find your own way around this. But this is going to give me my final answer of a minus 3, and oopsie, makes that look like a 3, and then a plus 1. All right, so that's basically it. Have a go at that and then see how that works. Now, on the next page, I have got the same problem here again, but this time I want to go about it using a different sort of method, which is to expand all the brackets. So that's now going to give me a square there. That is this a square. Then when I expand this bracket, I will use FOIL or whatever it is that you normally use, but it is this bracket multiplied by itself. Okay, so that's going to give me plus a square plus 2a plus 1. And then I'm going to subtract out the exact same thing that's going to happen to that. But this time I'll put it in brackets. A square plus 4a plus 4. And I need to prove that I'm going to get what's on the right hand side. Well, combine the things that are the same. So a square and a square give me 2a square plus 2a plus 1. And then expand this bracket with that minus, gives me minus a square minus 4a minus 4. I can now subtract the 2a squares there, giving me a square on its own. I can now subtract the 2a from that 4a there, giving me minus 2a. And I can do that 1 and that minus 4, give me minus 3. And this is exactly what we had on the page before. And we already know that that works out to a minus 3 and a plus 1. And that's our algebraic proof. We say that that's equal to the right hand side. I forgot to write that on the last page, but that's equal to the right hand side. Okay, let's move on. Here we have another situation. Feel free to pause the video here and have a go on your own. But I'm just going to go straight for it. So here, I don't have difference of two squares. I've got two squares actually adding, so I don't really have a choice. I'll have to expand these two brackets and then prove that I'm going to get that. So let's go for it then. So this gives me a square plus 2ab plus b square. Try and remember what I said before. Don't just square the a and square the b. You have to multiply the bracket by itself. That's what that square means. Okay. Plus a square minus 2ab this time plus b square. Okay, so we're going to try to see if we can get it to equal to everything that's on the right hand side. Well, see what we can combine. I've got a square and a square there, and that gives me 2a square. I've got 2ab minus 2ab. Well, that's the same thing, so they're going to cancel each other out. And then I've got b square and b square there. I can combine those, plus 2b square. My common factor is 2. If I bring that outside, I'll have a square plus b square. And that is equal to my right hand side. So I've shown my examiner that I can prove that this will happen. Okay, let's go. Okay, so here's our different situation that we need to look at. So let's quickly read it. Just to apologize straight away, this comma is in the wrong place. The comma should actually be here, but never mind. You are told that when two numbers have a difference of 2, comma, the difference of the squares of these two numbers would be the sum of the two numbers, and we want to prove that this is true. Well, let's try it out with some numbers first. So let's start with 7 and 5. So these numbers have a difference of 2. If I were to subtract it, I'll get 2. Now what this is actually saying, let's take it a bit at a time. So two numbers, they have a difference of 2. So I've already established that here. Then it says the difference of the squares, which means I need to square the two numbers and then find the difference. Well, let's square it. Square of 7 is 49. And the square of 5 is 25. And we are finding the difference of them. So when you find the difference, you're going to get 24. Now let's carry on the question just a little bit at a time. So it says now the difference of the squares of these two numbers is twice the sum of the two numbers. Well, let's find the sum of the two numbers. The sum of 7 and 5 is 12. So what they're saying is that the difference of the square, so when I square the two numbers and I subtract them, the answer I get is double the answer I would get if I were to add those two numbers, which is true because double 12 gives us 24. Well, I've just tried it out with numbers, but I haven't proven it, and it has to be proven algebraically. This is why this video is called algebraic proof. So let's prove it algebraically. So what I'm going to do, I'm going to define my two numbers as n plus 2 and n. Okay, so these are my two numbers. This is my first number here, and that's my second number. If I were to subtract them, then my answer would be 2. Okay, so I've already established that of these two numbers, the difference between them is 2. Let's carry out the same experiment now. So what I'm going to do is I will square this one and square that one, and then prove that I'm going to get well, let's do it a bit by bit. Let's find the square difference of them. So square this number, square that number, and then subtract the two answers and see what we got. Okay, so let's go then. Once we square this, we're gonna I'll probably just put brackets around it to show you that I'm squaring it and then squaring that number. So once I square it, I will get n squared plus 4n plus 4. Okay, let's get this writing properly. N squared 4n plus 4, and then take away n squared. Okay, so all of this is that, and then this is just that. Well, the two n squares will interact and they will subtract each other out, so that's gone and that's gone, leaving me with just 4n plus 4 as the difference between the two. If I want, I can factorize it. I might just factorize it on the side because I don't know what great tidings that will bring. So n plus 1 there. Okay. All right, so now that we've established that this is what we're going to get, let's go back to the question. So the question said that once I find the difference of the two squares, it should be double what I would get if I were to add my two numbers together. So these are my two numbers here, which are n plus 2 and n, and if I add them together, I will get 2n plus 2, which is, if I factorize this, this becomes 2 into n plus 1. Now if you look at it very carefully, you're going to notice that this is double that. So if I were to pretty much multiply this by 2, I will get that answer there. So this is now proven, yeah, to show that double the sum gives you what I would get for the square difference. Okay, and that's how you prove a problem like that. Okay, let's move on. Now, this is a question that came up on the June 2015 Edexcel paper for GCSE Higher Tier, and lots of people have been tweeting about it, and I've decided to include this question in our discourse. I'm not going to do the second bit because that's pretty much child's play. Let's sort this out. So you could have gotten your marks for this. You can clearly see it is a quadratic equation which you could just plug in your formula and sort yourself out. It's not a big deal. So I'm not going to solve that. That's going to just be a waste of time. Let's go to this bit here that lots of people got confused about. So there are n sweets in a bag, so in case you're one of those people that like seeing it, I'm going to literally draw a bag and put n sweets in that bag. And of the sweets in that bag, 6 of the sweets are orange, so you've basically got 6 orange sweets in the bag, and it says the rest of the sweets are yellow. So if you've got 6 orange and there are n sweets in the bag, then your yellow sweets would be n take away 6. Okay, so that's going to be your number of yellow sweets in the bag. The total number take away your 6 orange sweets. Okay, so let's have a look at what Hannah is up to. Hannah takes at random a sweet from the bag, she eats it, and then she takes at random another sweet from the bag and she eats that. what's the probability that she eats 2 orange sweets? Well, if in case you're worried about it, then it's a simple job of these are independent events. You draw yourself a quick tree diagram. So if Hannah picks a yellow sweet from the bag, then the probability of, so I'm gonna go, this is gonna be my yellow, that's gonna be my orange, okay? If she picks a yellow sweet, actually I don't really care about that, to be honest, because they just want us to focus on the fact that she picks 2 orange sweets from the bag. So let's just go straight for the orange. I'll call this orange, call that yellow. So this is going to be yellow here. This is going to be my orange here. Now, when she picks her first orange sweet from the bag, she's actually picking from 6 out of 10 possible sweets in the bag. Sorry, not 10. I mean to say n possible sweets in the bag. 6 out of n. Okay, so that she picks and she eats that. So there are no longer n sweets in the bag. There's literally n minus 1 sweet. So when she goes, so this is the first pick here. This is the second pick. When she wants to pick the next orange, so this is going to be yellow here now. Okay, and up here I'm going to have my orange. When she picks the second sweet, she's already eaten an orange. So there's five oranges left in there, 5 orange sweets left in there. And they're no longer, once she's eaten a sweet, there's no longer n left in the bag. There's actually n minus 1 left in the bag. And now they're saying the probability that Hannah eats 2 orange sweets is 1/3, and show that you're going to get this. So basically 2 orange sweets means an orange and another orange, which means you need to multiply. So let's go over this then. So this is her first orange, 6 out of n. And another orange, and means you multiply 5 out of n minus 1, and they've already told us in the question that the probability is going to be 1/3. So basically all I need to do is simplify this. Well, let's multiply the fraction out. Multiply the top by the top and the bottom by the bottom. That's going to give us 30 at the top, and then n into n minus 1 at the bottom. That's going to be 1/3 there. I'm now going to quickly cross multiply this times 1, that times by 3 there. So 30 times 3 is 90, and n into n minus 1 times 1 is just n into n minus 1. And all I got to do is expand this bracket over here. That's going to give me n square minus n. This 90, it's a plus 90. Bring it over the equal sign, it becomes a minus 90. And now I've got nothing left on that side. And this is now proven. Okay, and we're done with that. All right, so that was the big scary question everyone was tweeting. Everyone were tweeting about on the day for your GCSE, but it wasn't really that bad.